In section 2.7, we're adding one more little trick into our tool bag for solving equations, and that's going to be solving proportions. So our objective, again, is going to solve and apply those proportions in different sorts of questions. First one, again, is the one we're going to skip over, but it's always good to look back if you want to see if you understand that concept. We will explain it in that next paragraph as well. Question above, the number of red beads and the number of blue beads would be quantities that have a proportional relationship. So again, I think that would be red beads as the bigger ones here and the blue beads as the smaller ones, since we don't have those in color. And what that means, if they're a proportional relationship, is that the ratio of the quantities is constant. Even the quantities themselves can change. So for example, I can just look at the 2 red beads, 4 red beads, 6 red beads, and if I group that together with the 3 blue beads, 6 blue beads, 9 blue beads, I'll see that they're always in the same ratio. And at each stage of making that necklace, if I was to add more beads to that necklace, the ratio of red beads and blue beads would be the same. It would always be a ratio of 2 to 3, because that takes 2 red beads for every 3 blue beads. And if I'm going to use that to solve problems, proportional relationship can produce an infinite number of equivalent ratios. So I could have different sorts of fractions, basically, that we could set up. Any 2 of these can be used to make our proportion. A proportion is an equation that states that those 2 ratios are going to be equal. So it is going to be an equation. An example of a proportion would be A over B equals C over D, where B and D can't be 0 because, again, we can't divide by 0. So again, that would be our example of a proportion. And one way we read those proportions, I know I said over, but we could read that as A is to B as C is to D. So kind of like an analogy. If 2 ratios are equal and a quantity in one of the ratios is unknown, so again, you want to be thinking a variable there, we can write and solve a proportion to find that unknown quantity, or in our equations to find that variable. And let's try that at the bottom of the page. We want to find the solution of the proportion x is to 7 as 4 is to 5. So if I set that up and solve, I can see that x over 7 is just basically a division question. So we could have even had this question at the very start of the chapter. If I want to solve this in one step, to isolate that x, I need to do the opposite of division, which is to multiply. And again, multiplying both sides by 7 here is going to be easier if I write that as a fraction. X over 7 times 7 over 1. Our 7's will cancel, so I'm left with, the 7's will cancel, so I'm left with just the x. And on my other side, if I take 4 over 5 times 7 over 1, there's no cross simplifying I can do. But if I multiply the numerators, I get 4 times 7 to be 28. Denominators, 5 times 1 is just going to be a 5. So I get my answer is just 28 over 5. And again, improper answers are always fine in terms of our fractions. So cut off a little bit there, but it says in the proportion A is to B as C is to D, the products AD and BC are what we call cross products. You can use the following property of cross products to solve those proportions. And another way you guys might have heard this referred to from before, so you guys might have done this work before, is just cross multiplication. So when you think cross products property, you can also just think cross multiplication. And what that's saying is that the cross products of a proportion are equal. And if you have seen cross multiplication before, that just means if you start with that same proportion, A to B is C to D. Then if I cross multiply, I multiply the numerator of our first fraction times the denominator of my second, and again the denominator of my first fraction times the numerator of the second, I know that A times D will be the same as the product B times C. So we can write that out here. And if I'm given that example, if I have 3 over 4 is the same thing as 9 over 12, if I cross multiply and take those cross products, 3 times 12 will be the same as 4 times 9. So I know that 36 is the same as 36. And remember, we never test on knowing the name of a property, so if you'd rather just think of this as cross multiplication instead of cross products, we can use that to solve. So I'll try to use that in that first question, our first proportion. I wrote a little bit over it, but it starts y over 3 equals 3 over 5. And again, if I'm applying that cross products rule and cross multiplying, I know that if I multiply the top of the first fraction times the bottom of the second, that's going to go as a pair. That's going to be y times 5 to make 5y. And then if I do the same thing and group my denominator and numerator for the second pair, 3 times 3 is going to give us a 9 for that right-hand side. So if I know that 5y is equal to 3 times 3, I can take both sides and divide by 5. Again, it should only take one step. Since I just start with multiplication, I can undo that by dividing. And I'm left with the answer y would be 9 over 5 as a fraction. Again, improper is fine. So again, if I'm given that second proportion, 3 over 5 equals 13 over b, I could solve that either using cross products or by multiplication property. And you don't have to flip back to it, but I'll see really quick. Multiplication property is again just multiplying the same amount on both sides. So we could solve it that way. Although I think I would prefer cross products here. It's always your choice, but cross products I think is simpler because you kind of get rid of both multiplications at once. If we multiply 3 times b, again top times bottom, and again bottom times top, so 5 times 13. If I cross multiply, I'm left with 3b equals 5 times 13, so I know that 3b is going to be equal to 65 after I simplify that. And again, just taking one step from there to get rid of multiplication, I divide on both sides, and I'm left with my answer 65 over 3. And again, improper fraction will be fine in terms of an answer. So another proportion that we solved this time, I have a couple different variable terms. N over 5 equals 2n plus 4 over 6. So starting again with cross multiplication, n times 6 equals 5 times the quantity 2n plus 4. We do have to make sure, though, on that first step, the common mistake is just to take the 5 and multiply only by 2n and leaving the 4 the same. But remember, since 2n plus 4 is grouped together all as one numerator, I want to group that together with parentheses if I'm doing my cross multiplication. So 6n is easy enough, but when I multiply 5 times that numerator, I got to make sure that numerator stays in parentheses because what we're going to have to do is distribute the 5. So if I take that 5 times the first term, 5 times 2n is going to make 10n. And also if I distribute the second term, 5 times 4 is going to make that a 20. So want to make sure that we have a 20 there, not just 10n plus 4. From there, though, all we have to do is make sure that we have a variable on one side of the equation. And again, I think the quickest way here is to take our variables and get them on the left. So that means I've got to cancel out this 10n by subtracting 10n. Whatever I do on the right, I got to do on the left. So my next step should look like negative 4n equals, again, 20 is the only thing left on that right side. So from here is just one more step to get rid of that negative 4. Remember, this is still multiplication, it's not subtraction, so I have to divide both sides by negative 4. And 20 divided by negative 4, being careful with the signs, is going to be a negative 5 as an answer. So next, if we're trying to model our real world situations, we have to also make sure to write the proportion carefully. Easiest way to make sure our proportion is written correctly is that the numerators have the same units and the denominators also have the same units. They don't have to be the same from top to bottom, but they should be the same going across your question. So if I'm trying to set this next one up, an 8-ounce can of orange juice contains about 97 milligrams of vitamin C. About how many milligrams of vitamin C are we going to find in a 12-ounce can instead of an 8-ounce can? So if I'm going to set up a proportion to solve that, again, listing the units is going to help me decide which part to put that for my proportion. It doesn't have to be ounces on top. You could have also solved this with ounces on the bottom of your proportion. But I matched the 8-ounce can to my 97 milligrams because I know that's how many milligrams fit in that smaller can. And our unknown is how many milligrams are in our bigger can. So I listed that as my proportion. That'll be the same as 12 ounces to an X number of milligrams. And again, we have the numerators at the same units. They're both in ounces. Denominators have the same units. They're both in milligrams. So now I know that my proportion is written with the right pieces in the right place. And from here, remember, all I have to do is think cross multiplying. 8 times x is going to give me one product, so that's 8x for my equation. And 97 times 12 will get me that other cross property. So 97 times 12 is going to be the other side of that equation. We can ignore the units for now. We'll just have to go back and remember to put units at the end of our work. So if I simplify 97 times 12, I get 1,164. And again, if I want to get rid of that multiplication with 8x, I can just take one more step and divide both sides by 8. So if I get my answer as a decimal, that should be fine. That would be just come out to about 145.5 milligrams. So make sure you have these notes complete, and remember we'll work on some practice together in class.